Hi, so in this tutorial we are going to be talking about arrays. What we're going to be talking about is array operations. Basically we are going to cover most important operations and basically how you can use them, and also their performance implications, because with arrays you usually have to sort through them and some operations are more complex and complicated than the others. And for some operations you also have to traverse the whole array, so we're going to talk about that. So let's first pull from the array and type array. And in here, you're gonna see a bunch of functions. Before we start, let's just talk generally about arrays. So array is basically a list, indexed list of items, and items can be whatever you want them to be. So right now we have integer set up, but it can be Boolean, string, or any other type. And then this list can be populated by items, and they're going to be sorted automatically from 0th index to however many items you add. And we can actually populate it right away, so let's do some random numbers. Now that we have this, let's actually try to work with it. So let's type array again. And in here, let's first start from add. Basically, we just want to resize the array and add one other value at the end. So if we do something like this, let's also print to just see what happens when you change something. And let's give us 5 seconds. Also, I'm gonna need to add this array into the level. And let's click play. And you can see our last index is 5 here. I'm also gonna increase the size here, just so we have some more time. Okay, so add is pretty simple. This usually is, if you're familiar with the big O notation, the complexity is usually O of 1, meaning it is a constant price to pay for adding a new element. While this for each loop is O of n, meaning however many items in an array you have, this function is going to be more, or operation is going to be more and more costly. So going through 100 items is going to be 10 times more expensive than going through 10 items. So that's kind of a thing to keep in mind. While add is just basically expanding the array and adding just another item here. Next thing that we can do is let's do add unique. And this one tries to add an item if it's unique. So if I type 6 and we already have 6, let's click play. We can see how the 6 is not added at the top, so it should be like a first element. But since we already have 6s inside of our array, it did not add unique. Now this is nice because you are gonna check each element and make sure it's not the same as what you're adding. But the complexity is gonna be O of n, meaning it's gonna be more complex the bigger size of the array. So that's kind of a thing to keep in mind here. So if you don't care if it's unique or not, use add, but add unique can help if you want a unique element. Okay, let's type array. Let's see what else we got here. Then we have append array. This basically combines two arrays. So you have one array and then you add on top of the other. My understanding of how this is done is this array has a bunch of items, another array has a bunch of items, and they're basically just added on top of each other. This is usually O of n complexity as far as I know, meaning the bigger the second array is, the longer it will take. The complexity is gonna rise the bigger the array is, so yeah. Okay, let's see what else we get. Clear is pretty simple, it just clears the array. So if we have 4 elements, it's just gonna clear everything and I'm gonna have 0. As far as I know, in the background, how this does is it just resets the counter to 0 for the array, but it doesn't actually clean up the memory. But it's kind of the same thing because you already have memory allocated and stuff like that. So yeah, clear, pretty simple. Contains item and find item do similar things. So let's do first contain item. So basically you pick an index and see if that item exists or not. So if I pick, let's not delete this, but let's move it away just so we can test this. So if I do something like this and I try to find index number 22 and click play, we can see it says false because we have only 5 indexes, but if I try index 2, we get true. So that's kind of the general idea. And then we have find item, and this kind of does the similar thing, but it doesn't check if it exists or not. It actually gives you back the value. So if I type 2 in here, And let's connect it here. We get 1, so that's contains and find. Let's do array again and see what else we got. So for each loop and for each loop with break is a similar thing. The only thing is that for each loop is gonna go through all of the values, unless of course it's in a function and you break it or return. But for each loop is gonna go through all values, while for each loop with break, you can basically stop the execution of the for loop if you got the value that you wanted. Potentially, for each loop can be less costly if, let's say, your array has 800 items and you stop at item 50. That could be less costly, but I think overall for each loop with break is a little bit more costly just for each value when you're checking it, because it has the additional thing to break. But in general, yeah, it's pretty good if you need to just stop at any point instead of going through the whole array. Get a copy and get a reference is kind of self-explanatory. So we set an index and then we get the number from there. So let's say 2, we should I think get 6 for this one. Yeah, we get 6. So they do similar thing. The only thing is that get a reference, it would be nice maybe to, if they wrote like a get ref or something instead of just get, so it gets confusing. But the difference is that get by reference has this diamond shape here and basically tells you you're getting the value directly instead of its copy, which basically means you can directly manipulate this value. So what I can do is set by reference. We can do something like this, and let's do 12, something like this, and I'm just gonna go through the array and print everything. And we can also remove this unique, we're not using it anymore. And you can see how our first value is changed to 12. So that's kind of the general idea. And if we connect our get copy and we connect it to this and try to play, we can see how it's not changed to 12. The difference is that we're changing the copy instead of the value directly. Okay, so that's set by reference, or sorry, that was get. So let's type array again. Identical, this compares two arrays. Now this is gonna be a bit more expensive, or it's gonna be O of n. Basically, you're gonna have to traverse arrays and compare them. So usually how you do this in the background is for each element in this array. So let's say the first array has 4 elements and the second one has 3 elements. So you just traverse this array and do comparisons to see if they're same, and if at any point they are different, you can say, okay, they're not identical. So kind of the worst case would be O of n, but usually it would be even less, because you can basically do some optimizations with it. Let's go to the next one. Insert. So basically you can just add an item into an array, and this one can be a bit more complicated because you're not adding stuff at the top of an array. So with add, what you're doing is you have your array and you're basically saying, okay, we have this new value, we want to add it at the end. But insert wants to put it somewhere in between usually. So what's going to happen is you want to do, let's say, okay, we want to put this value in here. So what we have to do is, if we have 0, 1, 2, and 3 for indexes, what we need to do then, change this index to 3 and this index to 4. So we can set this index as index 2. So that's kind of what we are doing. And then it's going to be, the worst case would be like O of n. So if we want to put this at a point of 0, then we have to set 0 to 1, 1 to 2, 2 to 3, 3 to 4. And that's kind of the worst case scenario. But yeah, so it's the complexity would be O of n. And usually you don't really want to do this for big arrays, but yeah, sometimes you just need to insert something, especially if you have like a sorted array or something. Putting something at the end might not be doable. Okay, insert. Let's continue. So we have these two. I don't think we need to even show you like practical examples. So it's basically a Boolean check. Is it empty? Is it not empty? Pretty self-explanatory. Then we have is valid index. Basically checks if it's greater or equal to 0 for the index. So this can be useful if before you use the index to get an item from an array, you can just check if it's actually valid. If it goes below 0, it basically means you cannot go to array, because the array start from 0 index and then goes up into positives. So that one is pretty explanatory. Then we have last index. It just gives you the last index in the array. So for our array, it will be array index 3. And these are all O of 1, meaning the complexity is kind of set for any size of the array. You don't have to worry too much about the complexity for these ones, even if your array is getting really big. Then you have length. This is basically how big is your array, but for this one, you have to keep in mind that it gives you a total number of items, not by indexes. So this is gonna be 4. So if I try to print, we get number 4 instead of 3, which would be our last index because it starts from 1. Okay, let's then go to the next one. Now you have random array element, and random array element from stream is basically you just get a random element and it gives you integer and index, or it would be item and index. And from stream, it's kind of similar thing, but you can then put stream seeds, so you kind of get same values based on the seed. So yeah, depending on what you want, you can use either of these. Remove index. So this one is kind of similar to insert, because what happens with this one is you have, let's say, 4 elements and you want to remove this one. What you have to do is then shift these two to the lower positions. So this would be index 1, then this one needs to become index 1, and then this one needs to become index 2 instead of being index 3. You're kind of removing and then repositioning stuff. So worst case scenario, or when your complexity will rise as your array rises on average for this one. Then we have remove items. So before we select by the index, then we can select by the item. So what I can do is, let's do something like this. So we can try and remove 6s. So let's click play, and we are left with 1 and 2 because we had 2 6s in our array. Similar thing, but you remove with items instead of indexes. Then we have resize. So we can basically start shaving off values if you want the array to be a specific size. So I can put maybe 3. Click play, and you can see we removed the 1. And if you go back and look at the array, that was the last index. So basically what you're saying is at what point you want to shave off the rest of the indexes. And this, of course, worst case scenario or when. But at that point, you better use clean if you want to clear out the whole array. And let's see, we have a few more left. Resize, reverse. A reverse basically means you just want to swap elements around. So if we do this, click play, and we get 6, 2, 6, 1. Now let's do it without reverse. We get 1, 6, 2, 6. So basically we reverted. So we went from this guy to this guy. Or we went from bottom to and then from top. So that's kind of the general idea. And reverse for each loop is kind of self-explanatory. So for each loop goes from 0th element to the nth element or the last element. And reverse, it goes from the nth element to the 0th element. So I don't think we have to cover that. Then set array element basically means we are gonna get a specific value from the index and then set it to something else. So let's say our 0th value is 6, but we want to set it to 15, let's say. We're basically gonna do something like this. So let's move, click play, and we can see now it's 15. The complexity doesn't matter generally for the size of the array because you're just accessing a specific array index and changing a value. The one thing that you need to worry about is if you, let's say, set index to 8, and we also need to click size to fit. That means basically we're going to increase the size of the array and then add zeros. Yeah, keep in mind, if you set the index bigger than your array, you're going to be adding values and your array is going to become bigger. So that's kind of a thing to worry about with set array element. You kind of have to be intentional with this. You don't want to just increase the size of your array. And usually what you can do is get last, or we can just do last index. And then if you do this, you can kind of add it at the end. But at that point, why not just use add, which basically does the same thing. So yeah, let's see what else we have left. Shuffle, this is going to increase with the complexity of your array, the performance, because you have to go through each element and then shuffle elements around. So if we do this, let's shuffle a little bit, see what happens. 6 to 6, 1 seems similar like the first one, but this one looks different. So we just randomize the elements in the array. Then shuffle from stream, that's kind of self-explanatory. Same as the, random array from stream. You can kind of have same, quote unquote, same randomness because you selected same seed. Then we have swap array elements, and this is self-explanatory because it kind of tells you first and last index. So let's say we want to swap 6 with 1, so we would say 0 to 3, so let's do something like this. Now let's click play, and now we get 6 is to 1 instead of 6 to 6 1, I think. Yes, so we kind of covered, I think, all of them. And this is kind of the strength of the arrays, because you have a lot of operations that you can do on them. While if you use sets or some others, so let's say we want to use, oh yeah, we can do sets for these ones, but let's do integer. And I want to use a set here. Let's say set. So you can see you have less operations, and if you use, let's say, maps, change variable type, you can see you have even less operations for the map. Arrays are versatile, but sometimes complexity can rise really fast because you have to traverse the array, especially if you have nested for loops. So this is kind of, when you're using array, this is what you have to be careful with. So if I have, let's say, 2 for loops, so maybe I need to compare an element with each other element in the loop or something. So maybe, I don't know, equal, or it won't be equal here, it would be something else. But if you need to do something like this, complexity rises a lot. So what happens is it kind of multiplies with each other. So if this array has, right now it has 4 elements. So if you're gonna do 4 loops here and then 4 loops for each one of these loops, that means it's gonna be 4 times 4, which is 16. So n squared basically complexity for these two. And that gets exponential really fast, and it grows really fast. So if we, let's say, just doubled the element in here to 8, and this one just looped 8 times, it's kind of fine. Okay, we double in performance, that's fine. But then when we added the second one, it will loop 64 times, so that grows really fast, and you kind of have to be careful with this. Usually, ideally, you just want to have like smaller arrays and you loop them once. Or if you have bigger arrays or stuff like that, you can think of if the arrays are even the best way to store that data. So maybe you want to use, let's say, maps or something, because maps use hash tables, and that basically means that the search through the map is constant. So even if map had like 1000 entries, it's gonna be the same to search up a value instead of an array, where if you want to find some value inside of it and you have 1000 elements, the worst case it might be on like position 1000 or something. So you basically went from 0 and tried to search through each value to find it. So you kind of have to think about when to use them and for what you want to use them for, basically. So usually for arrays, you don't want to increase their size to be too big, so you kind of want to keep them smaller, because when you have lists of hundreds or thousands of elements, going through them or doing any when complexity operations can get costly. So for that, you usually want to switch off to something else, maybe maps, maybe sets, whatever is more performant. So yeah, that's about it for array operations.